Hi, Esther. Thank you so much for including me in your homework. And this is what you're doing for the next week or two. They're called radical square roots. I got you. This is lovely stuff. Not difficult at all. You're going to catch on real quick here. So I'm going to do a screen share here for you. And so just to recap, what is a square? A square is literally like we have a square. And if this is 3 squared is the area here, which is 9. And the square root of 9 is 3. So the question is this: what happens when that's not a whole number and we have something called simplifying a square? Simplifying a square, and you don't end up with a whole number. So I think the first one you have was root 45. So the square root of 45. Couple ways to do this. You can do a factor tree if that's what you're familiar with. And so the storyline I have for this is if you have a tree, you're only looking at the leaves. And the leaves would be the 5, the 3, and the 3. You're not looking at what I would call the branches. The branches would be like 9 here. Now, looking at the leaves, what I teach my students is if you have a date, quote unquote, pair of 3s, you get to go out, but you go out as a single couple, because the word couple is singular. Lonely here, no date, stays home. So the simplification of root 45 is going to be 3 root 5. Another way you could look at that is you simply ask yourself, what is a perfect square that's in 45? And that would be 9 and 5. And if the 9 is perfect, it gets to go out. And again, you get 3 root 5. Let's try another one of those. Here we have the square root of 30. Factoring. Okay, look closely. We look at our leaves. Nobody has a date. Guess what? You're done. You can't simplify square root of 30. It stays square root of 30. I think the next one was root 48. Factor tree. If it's even, I tend to just use 2 all the way down for consistency's sake. Let me reposition this here. I'm running out of space. Get this towards the top. Root 48 to 24 to 12 to 6 to 3. Now I look at my leaves. And in this case, I have 2 sets of 2s. So a set of 2 comes out. Another set of 2 comes out. No date, stays home. And these outer ones multiply. So the correct answer here is going to be 4 root 3. Another way you could have looked at this is there is a perfect square inside that, and that is simply 16 times 3. And if you're a perfect square, you get to get out of the radical like that, 4 root 3. Doing another one. Root 32. Factor tree. 2 and 16. 2 and 8. 2 and 4. 2 and 2. Looking at the leaves. Find your dates. I have a pair of 2s. They're going to come out. Another pair of twos, they're also going to come out. And this stays home. So we get 4 root 2. Another way you could have looked at this is there is a perfect square in 32. You get a singular perfect square, which is 16 times 2. 16 is perfect. And you get 4 root 2. You can spot those perfect squares. That's kind of a shortcut, if you will. The next one, square root of 8. Two comes out, so I get 2 square root of 2. The perfect square method, that's 4 times 2. I have 1 perfect square here. Therefore, that comes out of the radical and you get 2 root 2. Last one I'm going to do with you here is square root of 125. Factor that out. I know 5 goes in there, and I've got 5 quarters for $1.25. 5 and 5. 5 comes out, and this stays there. So 5 root 5. Another way you could have looked at that is simply the square root of 25 times 5. And 25 is perfect, gets to come out, and you get 5 root 5. Do you need more explanation or more problems? This is definitely a very simplistic. This is going to get more complicated. You're going to have to divide by radicals, and then things are going to be on the outside and all kinds of fun stuff. Oh, let me just do one of those just for good measure. Let's say you have something like this, 5 root 72. So this is called a coefficient on the outside. When we simplify this, so here I have a pair of 6s. They're going to come out. And you have a coefficient and multiply. So 5 root 72 is going to simplify to 30 root 2. So I hope that's helpful there, Esther.